Welcome to qnawire.
In this exercise, we have a particle that is subject to a potential energy function that's shown here in the graph on the left. The potential energy is 0 for x smaller than 0, and it's equal to U0 for x greater than 0. And the exercise tells us that the wave function psi of x is equal to a constant a times the exponential of I k1x plus a constant b times the exponential of minus 1k1x for x smaller than 0, and it's equal to a constant c times the exponential of I k2x for x greater than 0. And the exercise asks us to use the continuity of the wave function at x equals 0 and of its derivative at the same point in order to find constants c and b as a function of constant a. Here notice that k1 and k2 can be treated just as constants. Okay, so notice that the wave function at 0 from the left, so I'm just going to put a minus sign here, must be equal to the wave function at 0 from the right. And I'm going to put a plus sign in it. Okay, so the wave function from the left is a times e to the I k1x plus b times e to the minus I k1x, and this is equal to c times e to the I k2x. Now notice that if x equals 0, then the exponentials are all equal to 1, and we have a plus b equals c. This is one of the equations. Now we must use the continuity of the derivative. So we have the derivative from the left at 0 is equal to the derivative from the right at 0. So we have that the derivative of the wave function from the left is equal to I k1 times a to the e times e to the I k1x minus I k2 a b, and here's minus I k1, I'm sorry, b times e to the minus I k1x, and this is equal to I k2 c e to the I k2x. And at 0, and just canceling out the i's here, we obtain k1 times a minus b is equal to k2 times c. So a minus b is equal to k2 divided by k1 times c. So this is the other equation. Let me write them both down here. So we have the first equation. It's a plus b equals c. And the second equation, we have a minus b equals k over 2, k2 divided by k1 times c. And now I can sum the two equations, 1 and 2. So we obtain 2 times a, the b's cancel out, and we get 1 plus k2 over k1 times c. So 2a is equal to k1 plus k2 divided by k2 times c, which means that c, and I'm going to write it down here, c is equal to 2k2 divided by k1 plus k2 times a. This is the value of c as a function of a. Now we can go back to equation 1 and substitute this value of c. So we have that from equation 1, we have that b is equal to c minus a. So this is equal to 2k2 divided by k1 plus k2 times a minus a. So this is 2k2 divided by k1 plus k2 minus 1 times a. So this is 2k2 minus k1 minus k2 divided by k1 plus k2 times a. So b is equal to k2 minus k1 divided by k1 plus k2 times a. And this is the value of b, which concludes our exercise.